Hello everyone, welcome to the long anticipated introduction to GDB video. I wish I'd had this one put together weeks ago. I apologize for the delay. A lot of my health problems got in the way of getting this completed. Alright, I've got a pretty streamlined plan for what I want to do here, so hopefully it won't be a very long video. So I'm going to go ahead and just jump right into it. Alright, so GDB stands for the GNU debugger. So on Canvas you can find a copy of this code here. I'm just going to use GDB to sort of walk through this code and explore all the features of GDB in both regular, C programming language. It's also great for C++ and a number of other languages. I'm also going to take a look at some of the assembly functions that we'll need for the next project. All right, so let's take a look at this code. It's labeled GDB tutorial. Download it from Canvas. We can see I'm including some libraries. I've got one function here. It's a recursive function, so we can actually put a bunch of stuff on the stack and explore that. In main, I'm declaring some variables, num, sum, and string, copying some text into the string. We'll just go ahead and explore getting numbers out of these variables. I've got a loop here, so we can watch the loop, go through loop a couple times. Call my recursive function. It's just gonna count down 3, 2, 1, 0. In fact, let's take a look at that now. Yeah, if n is equal to 0, it's going to print blast off, print t minus, so rocket countdown. It's recursive. Here's the base case. Here's the recursive call. We're all done. We return. All right. I do have a couple places where there are going to be issues that come up frequently where we would use GDB to debug them. This is going to be a big one. A failure of malloc is going to result in a segmentation fault. There are very few things that I can think of that guarantee a segmentation fault. A lot of things just result in undefined behavior or things that are undesirable. This is one of them. So as you can see, I'm allocating a lot more memory than I have available. So this should give a warning too. All right. So let me go ahead, get out of this. We'll compile this code. One sec. Alright, so when we compile, in order to use GDB, we need to include the debugging features. This is going to keep track of all the variables, the names of functions. Actually, the names of functions are already kept track of, and the original source code. Without that, the compiler is going to optimize all that stuff away to reduce the size of the executable. -G will include all of those debugging tools. So make sure you add this option to use GDB. Let's see, I've also got the M32 for a 32-bit machine and all the warnings. All right, when I compile this, I can see instantly that that malloc line is going to be a problem, which is the whole reason we're using the debugger. Although the warning would probably take care of this for us. We're converting this giant number into a long, and that's going to give us this size at maximum, and that exceeds the maximum size right here that malloc can accept. There's just not enough memory available reserved on the heap, so this line's going to fail. It's going to give us a segmentation fault. All right, now let's go ahead and run this. We can see that it computes the sum in that loop, counts down 3, 2, 1 blast off, and then does indeed give us a segmentation fault. All right, so the command to get into GDB is very simple. It's just GDB, and then the name of the file we want to examine, and in this case, tutorial. So one of the things we can see right away, there's some version information, but reading symbols from tutorial. This is going to be reading in the variable names and all of the code. So this is telling us that it's there, that -G option was enabled. If we compile without the -G option, then it tells us that the symbols are missing. All right, now probably the most important command, we'll start with this one, is how to get out of GDB when we're done. The command is just quit, just like that. All right, obviously there's way more that I actually want to talk about before we quit, so let me jump back into GDB. Alright, so this tutorial is going to have about 3 sections to it. The first section is going to be just how to step through the code. We've got lots of options there to make this as easy as possible. Second section is about how to get information out of GDB about our variables, how to set the variables. And the third section will be specifically dealing with what we can do with the assembly part of this. So to start actually going through our code and executing each line and watching what happens, we've got 2 options to get started. The first one is actually called start. The other one is run. But start, if we don't take any command line parameters, all I need to do is type start. If we do have command line parameters, this is where I would enter them. All right, here we can see that when we type start, it's going to advance to the very first line of main, and it's going to stop there. Temporary breakpoint is set. This is the next line that's about to execute, line 7 of the code. Here, in fact, we can get a listing of the code right here by just typing list. This is going to give us approximately 10 lines centered around the line that's about to execute. Here, to get help about any particular command, we can just type help, for example, help list. This is going to say, here, with no arguments, list 10 more lines around or after the previous listing, or the current line that it's about to execute. With one argument, I can give it a line, and it's going to give me 10 lines around that. With 2 arguments, I can give it a starting and ending line. So let me just demonstrate one of those. So if I start at line 7, the beginning of main, and I go to line 22, it's going to print out the code for lines 7 through 22. All right. If I just want general help, I can just type help, and that's going to give me like lists of chapters. And so then I can go help, for example, breakpoints, and it's going to give me more information about breakpoints. All right. Where was I? So I just started. Let's see. If I type start, it's going to ask me if I want to start from the beginning again. Now this is going to stop at the very beginning of main. And from here, I can use the step commands or next commands to walk through that. I'll do that in a second. Before I do that, though, there's a second way to get started in GDB and to execute the code. Run is just going to advance through the code. It's not going to stop for us until it hits a breakpoint that we have to set, a watch point that we would have to set. The code finishes and returns at the end, or it crashes. So if I run this, I'm starting over, so yes. And this is going to advance through all the code. At some point, it prints out sum equals 24. It goes through that recursive function, t-321 blast off, and then it crashes here at this line. Very useful to figure out where your program crashes. If you were trying to debug by just putting in a bunch of print statements to figure out exactly what went wrong, this is much, much faster. All right, next up, just stepping through your code. I'm going to start it over. At the very beginning, I can see that line 7 is about to be the next one that's executed. I've got 2 options here. The first one, step, will advance through the code one line at a time. I don't have to type step over and over and over again. If I just push enter, it'll execute the previous command, which was step. So I can see right here I'm on line 8, or I'm about to execute line 8 into num equals 3. If I push it again, it does step again. The next line of code was int sum equals 0. Here's the code. So num is 3, sum is 0. After that, I can do step again. Now I can use the up arrow key. My previous command was list. If I type it twice, up arrow twice, I get back to step, so I can navigate through the history with the arrow keys. And again, I can just keep going, look at the code. It's about to do the string copy command. Then it's going to do num equals num plus 3. So at this point, num should equal 6. All right. The other way that I have to, here, let me keep going. I'm just going to push step a bunch of times. It goes through my for loop, and then it's going to hit this printf statement, and it's going to dive into the code for printf. So it's a step into. All right, now it's going to give me this message because printf was from a precompiled library. It wasn't actually part of our source code. I can do this. It's going to go through the the lines in printf, and it's going to do that. It's going to dive into this next function that printf calls. VF printf internal. Now I don't actually want to do this. In order to just advance through a function and get to the end, the command is finish, and I can see that it's now finished printf. It's telling me the value returned is 10. That's not the actual sum. The sum was 24, so it's not printing out what it actually prints. This is just giving me the return value of that function, which is a number in this case. All right, so next up here, let me list the code again. We can see, we're still in printf. Finish to get through that one. Value returned is 10. Now am I in the right place? Yep, okay. So the next line execute will be with this recursive countdown function. So I can do step. It's going to go into recursive countdown. It tells me this is where I just jumped in. The next line is this top line of recursive countdown. I go through, do my recursive check, or my base case check. Skip that. I can see now that it prints something out, and I'm again in printf. So I'm going to finish this step. Here's the n equals n minus 1 recursive countdown. Again, so here we are at the top of that. It's going to do the check. Now, if I want to continue without jumping into all of these functions, if I want to skip over printf, the command is next. So that's like a step over functions, whereas step is a step into. It always executes the very next line. But next we'll skip all function calls. So in this case, here's the print statement. We skip over that. The next line is actually this recursive countdown. So this will skip that and do the rest of the recursion and just finish here with the return. All right, there we go. List. We are back here still in the function. The next line to execute will be return. So we'll step through that. List. We're still, oh, that's right. We were 2 levels deep. So I'm just going to finish the function, run till exit from the recursive countdown. Listing. Still in there. I guess I was 3 levels deep. Next line to execute recursive countdown with n equals 3. Finish that. Oh, I am in the outermost frame. So here I am. Yeah, I just finished that. I'm back in main. Now if I do step, I can reserve some memory. That's going to fail. And then we get the segmentation fault. So that was step, next, enter, and then run and start so far. Next thing I want to do is talk about how to get basic information out, reading the values of variables, things like that. So I'm going to start over. Start at the beginning, yes. Let's take a list of the code. It's 7 through 22. Here we go. So I can see as I step through, first thing I'm going to be doing is jumping into that main function. The next line to execute is num equals 3. To print the value of a variable at any time, I can just type print and then the name of the variable that I want. Now right now, this line has not yet executed, so there's just going to be garbage in memory. In this case, I can see that it's actually been set to 0. Random luck that it happens to be a 0. That's not default initialized in C. This $4 is an internal GDB variable where they keep track of everything we've ever printed out. You can ignore that. All right, so I'm going to step again. That's going to do the n equals 3 line. The next line to execute is int sum equals 0. So now I can print num again. And I can see that it has now been set to 3. All right, if I do print sum, that one's not yet been set. Here we go. See, we've got garbage in there, negative 10,000. All right, but if I do step, now sum will be set to 0, and I can print out sum. All right, so if I just continue, let's see, I can see up the top, the next thing we'll do is we'll initialize an array of characters and then copy some text into it. So let me go ahead and step through that. Next line to execute was that. Nope, I'm tricking myself. That was the string copy. This is the next line to execute. Got to remember that, Mike. All right, so now that I've actually copied some text into that string, I can print string. And I see here that I've reserved 100 characters for my string, and I only copied in GDB is awesome. That's going to be automatically followed by that null terminal character, and then the rest of this stuff is just garbage that was already in memory and not being used as part of my string. All right, I should also mention that print can be abbreviated. In fact, most commands can be abbreviated to the minimum number of letters for GDB to uniquely identify which command it is. Some of them have even further shortcuts. So to print, I can shortcut this as just P. I can print sum, and now it's telling me that sum is actually equal to 9. Same as before, we've never changed it. I can P string, and it's going to give me the same thing again. The other really great way to get information about our variables is with the examine. So this is going to examine memory. The default, all I need to do is push X, and then I can give it the address in memory I want to go look at. So if I just do like examine num, this should fail because num is a variable, not an address. And it happens to be, I just requested information about address 3. That's not available. So what I need to do is use the ampersand to go, the address of symbol. And now I can go examine the address. By default, this is going to assume that I want to treat it as a 4-byte integer and take advantage of the fact that it knows that this is a little endian machine, and it's going to go ahead and sort out all of the hex digits, put them in the right order as an integer. In this case, it knows it's the number 3, even though the 03 is stored in the lowest order bits, so it's going to be in the backwards order. It's already taken care of that for me. All right. Interestingly, if I do examine string, I don't need the ampersand because this is already an array. Arrays and pointers are more or less equivalent in C. This is going to go ahead and give me the first 4 bytes of my string, GDB space, because each of those are 1 byte, but it's going to interpret them as an integer. One second, I'm going to go pull up the ASCII table. Be right back. All right, I've pulled up the ASCII table here. As I take a look at this first byte, the number 20 in hex, over here when I look at the table, I can see I need the hex column, that this is actually the space. So as it's interpreting this, even though the space right here is the 4th character, it's manipulated this to turn it into an integer. So this is actually printing it backwards because of the assumption it's an integer. And I'll demonstrate that a little further in a second. But let me just continue here. The 62 and the 64 are the next 2 characters. So I need the hex column. 62 is the B, 64 is the D, and 67 right here is the G. So these are backwards. I did space, B, D, G. All right, so GDB actually gives us a number of different modes to examine memory. The default was that integer version. All I need to do is put a slash followed by the mode that I want. B will give me an individual byte. This is actually going to change the default mode that it's set to bytes, so I won't need this again in the future. But here I go. I want to examine the very first byte of string, and what I find out is this is actually the 67, which was the last byte here, because this one was interpreted as a little endian integer. All right, so now I can see that the first byte at this actual memory address is in fact 67, the G. If I push the enter again, it's going to repeat that, but with the next byte. It's going to advance through the memory 1 byte at a time and give me all of the letters. 67 is G, 64 is D, 62 is B, 20 is the space, I, 69, let's see, right there is, yep, so looks good. If I want more information about all the options for the different modes I can interpret memory in, I can just do help X. Let me make this bigger. Let me do it again so that I can actually read things. This is where it's going to tell me that I've got all these options. Format letters include octal, hex is with an X, D for decimal, unsigned, char, string. So I've got all kinds of options. And I can also change the size of the data that I want to be looking at right there. All right, I think that's good enough for now. You've got enough information to go back and switch around the different options. One more thing I do want to mention. I can do more than 1 byte at a time if I just put in the number of bytes. So 10 bytes will begin at the letter string. And now it's going to print out all of the bytes, or 10 bytes, beginning at, here's D8 with the 67, G, D, B, space, I, S, space, 20, and then awesome, the rest of the word. All right, so next thing I want to do is talk about setting watch points and breakpoints. Breakpoints are very useful if I don't want to have to type step or next over and over, especially as my code gets longer. I can just put a point where I can say run to that breakpoint and then stop. So let me go ahead and we'll start over. List, whoops. Yes, let me get the code up. List 7 to 22. There we go, there's some code. Now if I want to set a breakpoint and stop, for example, on line 14, all I need to do is break 14. All right, and now, so I've started the code to advance to that breakpoint. If I type run, it'll start over and go to that breakpoint. Or I can continue, T-I-N-E, there we go, to breakpoint at line 14. All right, it's numbered it as breakpoint 6. If I want to get a listing of all my breakpoints, the command is info. And actually info has a number of different things that we can go look up. So I'll do help info in just a second. Anyway, info break will give me information about all of the breakpoints. I can see right now I've only got one of them set. At line 6, I've already stopped there. I've got some options for actually like hiding it or enabling it, the address and code where it's going to stop. All right, if I add a second breakpoint, let's go ahead and go after the print statement right here. We'll set a breakpoint for line 20, break 20, and then I can continue to that line. There we go. Line 20 is the next thing we're doing. If I step, it's going to go into the recursive function. There we go. I don't want to do that. Print function. So let's go ahead. I'm going to start over. I'm going to talk about watch points. So if I start, that's going to go back to the beginning. I can see that my breakpoints are preserved when I did start. If I do run, that'll start over, go to the first breakpoint. Breakpoints are again preserved. All right, but I want to talk about watch points. So check this out. I can watch. Let's see, where was I? Which line of code was this? I'm about to execute line 14, it looks like. Yep. So I should have, if I print out num, should be 3. After I execute it, num will be 6. Yeah, okay, now I know where I am. So what I want to do is I'm going to set a watch point on sum. So tell me hardware watch point. Now I'm going to continue. Now my next breakpoint was set down before that recursive function. If I have a watch point set, anytime I get to the variable sum and either read it or write it, so if I'm using it, if I change it, it's going to stop at that line and print out the old value and the new value. So sum equals sum, which was 0, plus num, which was 6. So after we do this, the new value is going to be 6. If I continue again, whoops, spell it correctly, that's going to advance through the loop and add another 6 to it. All right. Continue again. I can just type up arrow. There we go. Now it's 18. Enter. We'll do that again. Now it's 24. There we go. Then I printed it out, and then I hit my other breakpoint. Now check this out. This one's kind of important too. If I start over again, start the beginning, yes, and then I do info breakpoints, I can see that the watch point was removed. So watch points are not retained when I start over. It can be very useful, so you don't have to go back and clear them. In fact, info watch points, no watch points. So breakpoints include watch points. Watch points are just watch points. All right, there's another kind of watch point also. So regular, just ordinary watch will keep track of any time a variable is written or read. But I can also do a read watch point. Read watch. Let's set that to no. And now let me print the code. So right now it's read. Hit the hardware watch point line 11. I take that back. It's not line 11. This is they've numbered the watch points. This is number 11. So when I do continue, it's going to advance to, here we go, line 14. So it skipped over the place where it was set to 3 and advanced to the place where I've read it. So right there I'm reading it. I should stop again here where I'm reading it again. So let me continue. Oops. Continue. And now it's going to stop at, let's see, yeah, it's telling me the value is 6 at line 17. There it is. Right there. All right, excellent. All right, just some other really useful things I can do with breakpoints and watch points. Info break. All right, so when I do info break, that's going to be printing out all kinds of information about the breakpoints. It tells me what they've numbered them. This is an internal GDB number that I'm going to use to delete them or enable them or disable them. I can see that the different types. So I've got a breakpoint, and a read watch point. I'll skip both of those. The DISP is just tells us what happens after we hit the breakpoint. It's either going to be we'll keep it and it'll hit it. You know, if we go back through a loop and hit this again, we'll keep it. If we just want to stop after we get it once, this will be deleted after we hit the breakpoint. So those are the two options there. We can see that these are enabled. We can either enable them or disable them, and what address in the code they are and where they are in the C code. All right, so I've got some options here. I can delete breakpoints with delete. Here, let's get rid of breakpoint 6, and then info break. I can see I've only got 2 left. I can disable breakpoints. We'll do disable 7, and then up arrow twice. I can see now it is not enabled and will not stop here as I continue through. So I can turn them on and off. Delete without a number will delete all of my breakpoints, and it asks for confirmation first. All right. And there we are, no breakpoints or watch points. This does delete the watch points too. All right, so that was breakpoints and watch points. Next thing I want to do is talk about the call stack. So here I've gone ahead, started over, listed the code, and set a breakpoint at line 20, the beginning of my recursive countdown function. This is going to execute 3, 2, 1, blast off, so 4 times. So I'm going to continue to get to that function. Now I'm just going to run step a bunch of times, and I can see that I called the function. Here I called oops, get out of print, finish. There we go. There we go. Now I'm in recursive countdown. Let's do step. There we go. N equals n minus 1. Step again. Recursive countdown. In the next version, the next level of depth of recursion, n equals 0. Print. I want to skip over print. We'll step through this. All right, that's probably good. Let's see here. In order to get information about the call stack, I can use the backtrace command. And I can see that I'm actually at level 0. This is the second level of depth of my recursive call. If I go, so I started in main. I called the function once, right here with n is equal to, I called it with n equals 3. This one is going to be called with n equal 2. And then this is called with n equal 1. So that's where I am in the stack frame. If I do print n, I can see that at this level of depth, the recursive call is n is equal to 1 here. All right, these are all individual frames. So if I want information about variables in this frame, where I can see that n is actually equal to 2, I can switch frames. So I can go to frame. My frames are all numbered right here. So I can go to frame 1 to get information about variables. So I'll print out n in this frame. If I try and go get some data about like a variable in main, so if I print out sum, there is no sum in this function. It's a local variable to main. All right, when I do backtrace again, I can see that I'm still in frame 1 right here, even though there's not really a visual clue for me. Because when I print out n, I can see that n is still equal to 2, so I had to check it. If I go back to frame 2, that will be main. Now I should be able to print out sum. There we go. I've got sum as a valid variable in the frame main. I can switch back to any of these I want. Frame 0, that's always the top of the stack, the current frame that's being executed. Print out n, we see n equals 1. All right, so this is extremely useful if I have if I've failed at putting a base case into my recursive function. I will see that the backtrace is just huge if I keep going. And I can actually watch the variables and see that they, if I forget here, if I forget my base case, let's see here, I didn't quite print off enough. Here, 7 to 25. Still not quite enough. All right, list 3 to 100. That should be enough. Yeah, here's my recursive function. If I forget to put in the base case, which is a pretty common thing to do, the mistake I make all the time, I get excited about the recursive part. Anyway, the backtrace will show me that I've got lots and lots of frames. And eventually I'll get a Stack Overflow. All right, I want to wrap up this section before I dive into assembly with just sort of a grab bag of other commands that I find really useful. First one is kill. So I'm in the middle of executing my code right now. Kill will stop it. And then I can start over again. Start. There we go. So it didn't actually ask me if I wanted to start that time. Control C will also stop execution. All right, the next one, I've got a function recursive countdown. I can actually just call that function directly with call and then the name of the function. And let's give it a different parameter this time. We'll give it 5. Did I spell it right? Nope. All right, let me type that again. Pause. All right, hopefully that version's correct. And now I call the function. I can see that it's run again with the new variables. Instead of 3, 2, 1 blast off, I started at 5. So also very useful to call functions with like usually much simpler parameters to see if maybe something went wrong there. Ooh, another good one. Info locals. I think it just, yep. Let me actually list 7 to 22. We'll set a breakpoint at the line 16. We'll advance there. And now I've got some information stored in some local variables. Info locals will give me a whole bunch of information about all the local variables. So at that point, it's reserved some space for I, but in that for loop, it has not yet set I to 0, so there's garbage. Num is equal to 6. Right there, I added 3 plus 3. Sum is still set to 0. We haven't done this loop, and I've got my string. So it just gives me information about all the local variables present. If I had command line arguments, I can do info args. However, there weren't any for this particular program. I can do a temporary breakpoint that's only going to stop once. Here, let me do that. We'll do that at line 20. So t-break will stop at line 20. Temporary breakpoint set. If I do info break, I can see now that this keep versus display. Keep means that every time I hit that line, for example, in a loop, it's going to stop. As soon as I hit this breakpoint, it'll be deleted. So I'm only ever going to stop at it once. All right, I think that'll do it. Let me jump into the assembly part. All right, so to take a look at the code in assembly, here I've just listed the code, the C version. To switch all of this to assembly, the command is just disassemble. All right, and then it's going to print all of the assembly commands. I can see some really interesting things here that I just thought I'd point out. First, all of the call functions, I've got some nice color coding right here. I believe this one is the a string copy. I'm totally blanking on that name for a second. If I go down here, again, I can see I've got some jump commands. I've got all of the addresses in blue here, so that's very convenient. This is that for loop. And again, remember that the C compiler is a huge fan of turning everything into a do-while loop. So the very first thing we do is we jump down to address 5655629C right here, which is the condition. So it's going to do a comparison and decide whether it's going to execute the loop or not. This is I less than or equal to 4, I believe. And then if we do want to jump, if that comparison says do the loop one more time, it's going to jump back up to, and here, another way to look at this is main plus 101. All of these, so this column is memory addresses, like absolute memory address. This is the offset from the beginning of the function, which is the very beginning of that loop. All right, let's see here. Down here, I'm going to push return for more and talk about some more of the other interesting things we can see. It actually tells us right here we're calling printf. This can be a little confusing if you're using like only obj dump to just try and figure out your assembly code, because this will be some weird different formatted. It doesn't tell you it's printf. OBJ will tell you the names of functions that are in your actual code yourself, that you wrote yourself. So I can see here I'm calling the recursive countdown, malloc, again printf, and then the end right here, all the way to return. All right, I'm going to do one more little thing here. Let me quit this. Quit. Yep, here we go. We're back at the command line. I'm going to recompile this. GCC. I'm going to leave out the -g command, just to talk a little bit about what you can do if it has not been compiled with debugging symbols, with just the assembly that's there. All right, tutorial.c, and then M32, all the warnings to tell me that I never bothered to change that malloc error. All right, and then we'll do gdb tutorial. All right, now check this out. Reading symbols, no debugging symbols found, because I left out that -g option. But it still opens up GDB, and I can still list. Can't still list. Hold on, what's it called? All right, I looked it up. Sorry about that. It's examine instructions, and we'll do like 50 instructions. Ooh, how many fit on the page? Let's do 20 instructions. Beginning X, 20 I, beginning at main. Does that work? There we go. Okay, sweet. Sorry, got confused there for a second. All right, now these are the actual instructions in memory. I can see that I've got this, the string copy command again. It's exactly the same as before. Let me do a little bit more. We'll do that again to get the next 20 instructions. This still tells me it's printf, still recursive, still malloc. All right, so that's looking good. I can get information about the instructions. Again, that command was x, however many instructions I want, and the beginning address. And you can do help x to like get more information about how to do that. All right, so next thing I want to do is actually switch this over to assembly mode layout. Layout ASM for assembly. Now this is going to break this into a GDB like command option right here, and all of the assembly commands are going to be up here at the top. All right, I've resized my screen so that it's actually bigger for the recording. And that's going to mess up some of this border at some point as I'm stepping through, unless I don't go far enough. If you're using the native version where you haven't changed the screen size and you still get all 80 characters, should be just fine for you guys. All right, but the recording might mess up. All right, so if I want to step through the code, step doesn't work. Single stepping, which has no line information, it doesn't know where the next code is. It's jumped all the way down there. Let me start again. So there I'm at the very beginning. What I really want to do is step through the instructions, step I. That's going to go through the instructions one at a time. So there I am, main plus 4, main plus 8, main plus 11. Check this out. Right here I can see that all of the commands, they're not all 4 bytes. This one was only 3. That one is 3. Here, this next one is only 1 byte long. OBJ dump will actually give me the assembly version, or the hex code, the machine version of these. GDB does not give me that. So let's see. I can also do next I. Same way, step I. It's going to step through, but it will skip over things like this string copy call, which can be useful if you don't want to dive into all of the layers of string copy. And then I can also set breakpoints. Let's see here. So in this case, I'm going to set a breakpoint to, let's just advance to that address. So right there, 0x56556259. I made a mistake. How do I type that in? All right, I had to go look it up. I forgot the star. This is actually not, I was almost right. So instead, break star 0x, and now I can type in an address like 56556260. Now I've got a breakpoint set right there. I see the B+. When I do continue, it'll execute all of these assembly instructions all the way down to my breakpoint, and there I am. All right, I think that's going to do it for the assembly part of this. Have a great day, everybody. All right, guys, I was just editing the video, got all the way to the end, and realized that I never talked about that segmentation fault, which is a really common error, and GDB is a great way to deal with those. So let me just take 1 minute. I recompiled it with the -G option, so that list will actually give me the commands. They're all there. I'm just going to run this. It's going to go all the way to that segmentation fault, and it's still in command mode. So right here, I can still do print sum. I've got all my variables. Now, this is the line that gave me the segmentation fault. So the most logical thing to do would be to print out the value of text. It's already a pointer. And what I see here is that it's actually address 0. So remember the code. When I did malloc, right here, if malloc fails, it returns null, which is the value 0. So I can see instantly that malloc has failed. That's the reason that I have the segmentation fault, and I'm trying to write to a reserved memory address. All right, that's all I wanted to say. Thanks for letting me put this little extra bit at the end. Have a great day. All right, guys, wow, I'm not having a great day here with remembering everything I want to say. I completely forgot info registers. Let me start, and then layout assembly. All right, so what I'm doing here is I'm looking for, well, here, let me just, info registers will tell me the contents of every single register. In this case, it's just garbage from the start. I haven't actually done anything with my program yet. So I'm going to push Q to not list the rest of the registers. What I'm going to do is I'm going to just do next I, and I'm going to scroll down until I find a place where I'm moving something into a register. Yeah, here we go. Line 101. This is perfect. So right here, this is my loop where I was doing the add 6 every single time to sum. So 6 plus 6 plus 6. Right here, this line, I moved some value. This is the value from num, which was 6, into register EAX. So let's see here. Minus 78 from EBP. Right here, I added the 3. This is num equals num plus 3. Again, this is num. Somewhere up above, I moved 3 into this memory location. All right, does it let me scroll up? Doesn't let me scroll up. All right, trust me on that one. So if I do info registers right now, I just moved the value 6 into EAX. So I should be able to do this and find out that EAX contains the number 6. Timeout, Mike, what'd you do wrong? I see what I did. Okay, remember that everything that the compiler in C does, it loves to turn all of our loops into do-while loops. So I had just done the jump down to here. It never actually executed this line yet. So let me do a couple more steps. Step I, go there. Now we just moved it. Well, we're about to move it. Now we've moved it. Info registers. I forgot the S, but it's enough that it figured it out. Now I can see that register EAX actually contains the number 6. And remember in homework 3 or project 3, at some point all of the answers will appear in a register. So you can kind of just go through, find the right spot, keep track of where the answers are going to be, and identify them. It's really not that bad. Can't believe I forgot this command. Sorry about that, guys. That's 2 so far. Hopefully, if I think of anything else, I'll just add them to the end. Otherwise, have a great day.